Hi, my name is Miss Fung. Today we're going to look at permutations. Previously we saw factorial and we had a look at the number of arrangements of things in a row. We saw that when we had 5 things, it was 5 factorial, which was 120. If you don't understand this, please watch the previous video. Today we're going to ask the question, what if we had 5 objects but only 2 spaces instead of the whole 5? What would happen to the number of combinations that we can arrange this in? So we could also do the tree diagram like before. In the first slot, we can have A, B, C, D, E, so 5 things. In the second, we could only have 4 things left, or in other words, 5 times 4. And here are all the combinations of the 5 letters if we only had 2 spaces. We can have AB, AC, AD, AE, BA, BC, etc. So we can see that the number of arrangement is just 5 times 4, 20. I've picked only 5 objects and 2 spaces so we can find a pattern. Originally we said that factorial is n times n minus 1, etc. So if we had 5 objects, it would have been 5 times 4 times 3 times 2 times 1. But how do we just have the 5 times 4? Let's figure out a formula to make this work for any number of objects and spaces. How do we get 5 times 4 from all of this? Well, we need to get rid of this section over here. What is that section over there? How do we get rid of something? We would divide by that thing to get rid of that. And 3, 2, 1 is 3 factorial. But how do we get 3 factorial from 5 and 2? We get 3 factorial from 5 and 2 by subtracting. 5 minus 2 is 3 factorial. So what we had done is gotten rid of the missing spaces. So 5 factorial is if we had 5 objects all in a row. By dividing by 5 minus 2 factorial, we considered that there is not enough spaces. We have just these 2 spaces over there. So the new formula now is, if we have 5 objects and only 2 spaces, we would do 5 factorial over 5 minus 2 factorial. So this 5 minus 2 factorial is to get rid of the 3, 2, 1. So 5 is the number of objects, and we're going to do the other value. We're going to call it R, and it's a number of spaces that we have. So N, number of objects, R, number of spaces. So this is our new formula, and there's a name for it. It's called permutations. It's the arrangement of objects in a specific order, where N is the number of objects and R is the number of spaces. So let's do an example. Calculate 5p2. So we would write what we did before, so 5 factorial over 5 minus 2 factorial, and would evaluate it. So 5 factorial over 5 minus 2 is 3 factorial. So we would have the 3 factorials would cancel out, and we would have 5 times 4, which is 20. Let's do another one, 11p3. So we would write 11 factorial over 11 minus 3 factorial. 11 minus 3 is 8. And now we can cancel out the 8 from both of them, and we're left with 11 times 10 times 9, which is 990. Let's do another example. Example 2. 3 books can fit on the desk. See, 3 books. If there are 8 books to choose from, how many different arrangements of 3 books are possible? So the number of objects is 8. I have 8 books to choose from, but I only have space for 3, so R is 3. Or in other words, we have 8p3. So 8 factorial over 8 minus 3 factorial, which is 5 factorial. And simplifying, so dividing by 5 factorial would give us 8 times 7 times 6, which is 336. Example 3. How many numbers greater than 1,000 can be formed using the digits 3, 4, 5, 6, 7, and 8? So here we have 6 objects, but how many spaces do we have? Can we have 3? Like 3 digits, like 345? No, we can't, because that is less than 1,000. We could have a space of 4 because 3,456, for example, or 6,543 example is greater than 1,000. We could also have a space of 5, so 5 digits, or 6, but we couldn't have 7 because we don't have 7 things to choose from. So for the numbers greater than 1,000, we could have 4, 5, or 6 digits. So the number of objects is 6 and the number of spaces is 4 or 5 or 6. So we could use the formula 6p4 for the space of 4, or 6p5 or 6p6. And when we say or, we mean plus. So 6p4 on the calculator gives me 360, 6p5 is 720, and so is 6p6. And adding it all together, we get 1,800. I'll show you how to use the permutation in another video. Example 4. From a class of 25 students, a captain, a vice captain, and an assistant are to be selected. From the remaining students, a role monitor and a class organizer are to be selected. How many different ways can the positions be allocated? So initially we have 25 students and we need a captain, vice captain, and an assistant. So 25 students, and the space that we need to fill is 3. From the remaining students, so now we used 3 students already, so we only have 22 students, we need a role monitor and a class organizer. So from the 22, we need 2. So we need to fill this position, these positions, and these. So 25p3 and 22p2. And when we say and in mathematics, we mean times. So we have, put that in the calculator, 720 times 462, which gives us 5,040. Let's find some patterns. Let's say we have 99p1. What would that look like? That would be 99 factorial over 99 minus 1 factorial. Now 99 minus 1 factorial is 98 factorial. And 99 factorial over 98 factorial, we know it gives us 99. What about 11p0? So 11 factorial over 11 minus 0, which means 11 factorial over 11 factorial, which is just 1. So when we have r equals 0, we have npr to be np0, or in other words, n factorial over n minus 0 factorial, which gives us n factorial over n factorial, which is 1. When we have r equals 1, we have np1, which gives us n factorial over n minus 1 factorial, and that simplifies to be n. So the two things I'd like you to remember for this video is when r is 0, so np0, so anything p0 will always be 1, and np1 will always be n. Thank you for watching, and I'll see you next time. Bye!